Okay, we're recording Chapter 2 Study Guide. From the graph of the quadratic function f of x equals x minus 4 squared minus 1, determine the equation of the axis of symmetry. Your axis of symmetry is always x equals h. In this case, x is 4, so x equals 4. So that is the equation of my axis of symmetry. Whoops, I'm sorry. Because of the format of this, I'm going to go do number 3 now. Determine the x-intercepts of the quadratic function. So x-intercepts are when y is equal to 0. So we have 0 equals... I'm sorry, this is so messy because this stylus is so incredibly sensitive. So x-intercept is when y equals 0. Okay, so that means that 0 equals x squared. Forget, my hand keeps causing problems. X squared plus x minus 56. Okay, got something to block my hand. Okay, so we just factor this. We need factors of 56 that subtract to equal 1. Well, that's going to be 8 and 7. So we have 8 and 7. The larger is a plus, so that's the 8. So the zeros are going to be, remember the y was 0, so we're going to have negative 8, 0, and 7, 0. Y value is 0. So that gives us D. Number 2, we're going to go back over to this side of the page. Determine the vertex of the graph of this quadratic function. Well, we complete the square. So we have x squared plus x plus 5/4. Well, the coefficient of the x is 1. Divide that in 2, we get 1/2. Square that, we have 1/4. So we add 1/4 and we subtract 1/4 outside. So this gives us x plus 1/2 squared plus, well, 5/4 minus 1/4 is 4/4, which is 1. So our vertex is negative 1/2 because it's x minus h plus 1. So the answer would be C. Now we're going to look at number 4. Write the standard form. Let me move this out of the way. Standard form of the equation of the parabola that has a vertex at 3, negative 4. There we go. So we have y equals, I apologize. Y equals a times x minus 3 squared minus 4. So we know we have this. What we have to do is find a. Well, this one can't be right. So we have only x. Oh, this one can't be right, can it? Because that's got a plus 9 instead of a minus 4. Okay, so really we know now that it's that one. But if you didn't know, let's say you had 2 options. So let's continue the problem. We plug in this point for x and y. So we have negative 5 equals a times 9 minus 3 squared minus 4. So I'm going to add 4 to both sides. Now I have negative 1 equals 9 minus 3 is 6. Squared is 36. So I have 36a. Now I divide through by the 36. I get negative 1 over 36 is equal to a. And sure enough, that's what a is on this problem. Okay, so let's look at the next one. Number 5. Describe the right-hand and left-hand behavior of the graph. All right, so if we graph this in our calculator, that's what you want to do. first off. Okay, so go to the y equals screen. And we have 3x to the fifth. 3x to the fifth minus 12x cubed plus 8. Okay, if we graph this, okay, I am zoomed in too tight, so I'm going to change my windows to something big because I'm really looking only at the end behaviors, right? So I'm going to go negative 50 to 50 in the x direction. Maybe not. Maybe it's just the y direction I need to pull out. So let's do negative 20 to 20. Scale of 2. At y direction, negative 50 to 50 with a scale of 5. Now we graph it. Okay, so basically what I see is a graph that looks like this. And what we're looking at is the behavior at the two ends. So, because the degree is even, it is not. It has an odd degree. So it cannot be this one. Because it has an odd degree, that's good. Odd, odd, odd. Okay. Because the degree is odd and the leading coefficient is positive, which it is. Okay, they all say that. Okay. The graph falls to the left and rises to the right. It's when it falls to the left and falls to the right. This is not true. Falls to the left and rises to the right. Okay, so far that one's good. Let's keep going. Rises to the left. It does not rise to the left. And the last one says rises to the left also. It does not. It falls to the left and rises to the right. So we ended up with C. All right, let's look at number 7. Oops, I'm sorry. My hand again accidentally hit it. Okay. Number 7. Use long division. Okay, so I'm going to try to roll down a little to give myself a little more space. I have x plus 3. Sorry, too far. I have x cubed plus 3x squared plus 25x plus 75. Using long division, I take an x squared. That gives me x cubed plus 3x squared. Now when I subtract these, notice those two fall out. So now I have 25x plus 75. Well, what do I multiply x by to get 25x? 25. So I get 25x plus 75, which also falls to 0. So I have no remainder. So the answer showing remainders can't be correct. I have an equation of x squared plus 25, which looks like what I've got right there. So it's E. Find all real zeros of the polynomial f of x equals x cubed minus 4x squared minus 36x plus 144. Alright, so we're looking for find all the real zeros and determine the multiplicity of each. Okay, let's see. What is 144 divided by 36? 4. Excellent. That's what I want. So if I look at this, I'm going to do a... Oh, I'm sorry. I'm going to do a grouping. All right, if I take an x squared out of the first bit, I'm left with x minus 4. If I take a negative 36 out of the second, I get x minus 4. So that gives me x minus 4 times x squared minus 36. That gives me, if I set these equal to 0, I get x equals 4. I get x squared equals 36, which means that x equals plus and minus 6. So I only have one of each of those. Yes, I have the plus and minus 6, but that's a plus 6 and a minus 6. Only one. So I have 3 zeros, 4, 6, and negative 6. So not 2, not 1, not 2, not 4 and negative 4, but 6, negative 6, and 4. So the answer is number 6. All right, now we're going to use synthetic division. And we're going to, remember, we have to place these in order. So we have negative 3. All right, the x cubed is 4, the x squared is 30, the x is 44, and the constant is negative 30. We bring down the 4 times negative 3 is negative 12. I add, and I have 18. Negative 3 times 18 is 54, I think. Let's see. It's 54. Yay! Okay. So that means I have a negative 54. When I add, that gives me negative 10. This becomes a positive 30. I add and I get 0. So I have no remainder. Since I was an x cubed, this is now an x squared plus 18x minus 10. 4x squared plus 18x minus 10. There we go. So that's my answer. Okay, number 9. If x equals negative 3 is a root of this polynomial, use synthetic division to factor the polynomial completely. So what we're going to do is we're going to use synthetic division to divide out that negative 3. Okay, there's not a lot of space here. So I have negative 3, 1, 1, negative 9, negative 9. 1, negative 3, negative 2, 6, negative 3, 9, 0. So this leaves me with x squared minus 2x minus 3. This I can factor. Factors of 3 that subtract to 2 are 3 and 1. The larger is negative. Negative plus. So this means I have 3, negative 1, and negative 3. Okay, factored is going to be x. The positive 3 gives me x minus 3. The negative 1 gives me x plus 1. That didn't work. X minus 3, x plus 1. X minus 3, x plus 1. The negative gives me x plus 3. So that has the x plus 3. That has the x plus 3. Okay, then we got to look at our zeros. This one has an x minus 1, and that doesn't work. So we have negative 1, negative 1, negative 3, positive 3. That looks correct. 1, negative, no, they didn't flip the sign on those. So we need number 9. Sorry, we need A. All right, now, use the quadratic formula to solve. So we have the square root of negative b plus or minus the square root of b squared, 14 squared, minus 4ac, which is 4 times 46. 4 times 46 is 184. So 14 squared minus 184 is 12. So now we have 4. This is all over 2a, which is just 2. So we have 14 over 2 plus and minus the square root of 12 over 2. We put the 2 under each piece. All right, now I'm going to simplify this. 14 over 2 is 7. I only have one with a positive 7. But let's finish. 12 is 2 root 3. The 2's will cross off, so this is going to be plus and minus root 3. And sure enough, the answer is D. 10. Simplify. So we have to multiply by the conjugate. So we have 6 plus 3i over 5 plus 4i. And this has to be multiplied by 5 minus 4i. Alright, now when we FOIL the bottom, we get a difference of squares, which is 25 minus 16i squared. But I squared is negative 1, turning that negative 16 to a positive 16. Our numerator, when we FOIL, we get 30 minus 24i plus 15i minus 12i squared. But I squared becomes a positive. All right, now we're going to simplify this. 30 plus 12 is 42. Minus negative 24 and a positive 15 leaves me with a negative 9i. All over 25 plus 16 is 35, 41. Now I can put these under each individual one, but I also know that that's true. So my numerators should be 42 and minus 9, not negative. 42 is first. 42 over 41 minus 9 over 41. That's our baby. All right, let's look at number 12. Find all zeros of the function. Okay. X squared, oh, all this, that's easy, right? This gives us x equals 0. This gives us x equals negative 5. X cubed equals 8, so x equals, cubed root of 8 is 2. Cubed root 8, which is x equals 2. So there are 3 2's, right? So we have 2, negative 5, 8, and 0. 0, 5, negative 2. Okay, we got to have 0. So it can't be this one and it can't be this one. Find all zeros. We have 0, negative 5, 2. Now, why do we have all of this? Hang on, I'm going to pause you for a second. I'm sorry, I'm a ding-dong. We don't have 8. All this leaves us is 2. We have 2, negative 5, and 0. We have a multiplicities that give us the most, right? We know we have to have 2, 3, 6 zeros. The degree of this equation, if I multiplied all the x's together, would be 6. So we have to have 6 zeros. We have 0 with a multiplicity of 2 because of the x squared. We have 2 with a multiplicity of 3 because of this x cubed. And then we have 5 with a multiplicity of 1. Notice 1, 2, 3, 4, 5, 6. Our total multiplicity is 6. So that's fine. 0, 2, 5. Nope, negative 5, pardon. 0, 2, negative 5 is C. All right, we're moving down to number 13. We'll do 13 and then 15. Write this function as a product of linear factors. So we have to factor this thing. But if we look at it, you can't see me doing what I just did. Okay, if we look at this number, we can see if we factor out, I'm going to roll up just a smidge. If we factor out an x squared, we get x minus 3. Now look at these. If I factor out 25, I get x minus 3. So I have x squared plus 25 and x minus 3. All right, product of linear factors, which means we have to take that x squared down. So this is going to end up with x squared plus 25 equals 0. X squared equals negative 25. I square root both sides. I get x equals plus and minus 5i. Square root of 25 is 5. Square root of negative 1 is I. All right, so we have x plus and minus 5i and x minus 3. So that's our answer. Now let's look at 15 here. I'm going to roll down a little bit because we need a little more space to see all the answers. Find the zeros, if any, of the rational function. Okay, our zeros are when y is equal to 0. So for y to equal 0, we only need to care about our top equation. So I add 16 to both sides. I get 16 equals 9x squared. Divide by 9. 16 over 9 equals x squared. Now I square root the whole thing. Square root of 16 is 4. Square root of 9 is 3. So we have plus 4 over 3 and minus 4 over 3. Don't forget to do the plus and minus because we did a square root. Alright, we're down to the last two equations. Consider the function. Find the function's domain and identify any horizontal and vertical asymptotes. So, we're going to take 1 over x minus 6 squared. Find the function's domain and identify any horizontal and vertical asymptotes. So, domain means x equal 0. Okay, so we square root both sides. That means x minus 6 has to equal 0. X has to equal plus and minus 6. Okay, so if x is... Sorry, no. Just plus 6. X is 6 is a problem. So we're going to have to do the interval notation with parentheses at 6 going both directions. So notice that's what we've got right here. And there. So let's see if any of our other interval notations work. Oh, this is minus 6, so this can't be. This is regular 6. This one works. And the next one too. Okay, so we've only eliminated one by knowing that. Now let's see what are our asymptotes. Okay, x equals 6 is also an asymptote. So it cannot be negative 6. X equals 6, that one works. X equals 6, x equals negative 6. Can't be that one. Okay, so now we have to look at what is y equal. Remember we said to force the numerator and denominator to have the same degree. Well, the denominator, if I've multiplied that out, is x squared minus 12x plus 36. Who really cares about this part? This is what I'm looking at. So it has a 1. So I have 1, or 0x squared, over 1x squared minus 12x, da-da-da-da-da-da. Okay. It's going to be a plus. So my y equal asymptote is 0 over 1. So I have a y equals 0 asymptote, not a 1/6. I have a, I have a y equals 0 asymptote. So my answer is D. Alright, and now I'm going to erase this because I want to be able to show you the work for our one free response question for this test. Okay. Free response. Find all rational zeros of the function. So we have to look at our possible rational zeros. We have to graph it. So our possible rational zeros are our, sorry, that didn't work. Our possible, there we go. Our factors of 64, which are, it's 8 times 8 squared. So it's 4 times 16, 8 times 8, 1 times 64, 2 times 32. That's it. Okay. So we have to put each of those over the factors of 1 and 3. So we have, those are our possible factors. Now we're going to graph this thing in our calculators. Y equal, okay, we have negative 3, don't forget to do that, x to the 4th, plus 4x cubed, plus 52x squared minus 64x minus 64. Alright, I put this in my calculator and I graph it. I know I'm going to have 4 zeros altogether. I see 1, 2, 3. I see all 4 of them. Alright, so I'm going to actually zoom in a little bit. Well, first I'm going to go look at my table, see if I can get any whole numbers. Right? Okay, I have 2 whole numbers that I can see. Oh, I have 3. Wonderful. Okay, so I see on my table minus 4 has a 0 in the y value. 2 has a 0 in the y value, as does 4. So I only have one that has a fraction. Alright, so what we're going to do now is start dividing these out. So I have minus 3, 4, 52, negative 64, negative 64. Well, these numbers get real big, and as I progress, they'll get smaller. So I'm going to divide out the smallest number I have, which is a 2. It's going to be my easiest to do the math on this long of a problem. Okay, so bring out the negative 3. 2 times negative 3 is negative 6. Add them. Leaves me negative 2. 2 times negative 2 is negative 4. Add them. I have 48. 2 times 48 is 96. I add those. So 96 minus 64. 96 minus 64 is 32. Times 2 is a positive 64, so it gives me a 0. Yay! Prove that that's a 0. But I'm looking for this final 0. Alright, now I'm going to divide out of this one the positive 4. I'm saving the negative 4 because it's negative for last, because it's negative and it's also a 4. Alright, so negative 3, negative 12. When I add those, I get negative 14. Negative 14 times 4 is 52. So I have negative 52. This leaves me with a negative 4. It's not what I want it to leave me with, so I may be wrong. Let's see. Negative 14 times 4 is 56. Sorry. So this is 56. Let me erase what I have there. 56, which is going to leave me not a 4. That's going to leave me with a negative 8, which is what I want, because now 4 times negative 8 is negative 32 and gives me a 0. Yay! Now we're going to do the negative 4. Negative 4. I'm going to give myself just a hair more room. There we go. Negative 3, 12, negative 2, 8, 0. Yay! Now I have negative 3x minus 2. We set that equal to 0. We get x minus 3x equals 2. X equals 2 divided by 3, negative on the whole thing. So my zeros are x equals negative 2/3, 2, 4, and negative 4. Is that what I wanted was my zeros, or was I going for find factor? Find all the rational zeros. That's my answer right there. 2, 4, negative 4, and negative 2/3. All right, that's what I'm basically looking for. I want you to graph it. I want you to, sorry, somehow I jumped way away. Okay, I want you to graph it. I want to see the synthetic division dividing out your whole numbers. And then I want to see you factoring whatever results you're left with. So that's your free response. And we're done. Wow, that was like a